Hey everyone, how are we doing? I think we got the audio, we got the video, we got everything. Might get some people in the chat here in a moment. Let's wake up Mubot. Mubot can be in the chat too. Mubot, wake up. Waking up there. Got the lights. The lights make it so much more warmer in here. So much more warmer? Sure. So with that, I think I should be a little bit higher. I should be up to here. Used to be standing, but then my hips started hurting. Long story. I'm gonna pull up visualization or the data analytics assignments. How about that to start right here? Might be some questions on it. About the office hours, getting the thing going right here. And then we're gonna do some chapter 14, I believe. Let's start here with some data analytics. Data analytics, here we'll go stat 201. Data analytics. Executive summaries. And future research. Okay, let me get a little jump open here. And let's go to Pokemon. You know we love Pokemon here. Get Pokemon going. Get a little Word document going. And oh my gosh, got a billion Word documents. Oh, my computer's overheating. Okay, let's go check it out. So we're gonna talk about the data analytics here to start, the future research, all that good stuff, and what you need to write. So I like to point this out and check out the videos we have on this. If you're watching this video right now, go to the visualization playlist. Something like this. What is it? There's the visualization playlist. The visualization playlist has a bunch of tons of good videos in it where you can check out how to do these things for each thing. Where is the future research? Did I not put it in this one? No, I should go add it here. We'll pin the future research. Future research, executive summary, stat 201. And there's the video on it. Right there. Everything is fine. Everything's fine. I should have played this one today. Worked hard on this one. Edited myself into this. The meme. Gotta edit yourself into the memes. So with this right here, we're gonna drop this in. I'm gonna go over this too. This is the future research video I've just pinned. It's the current link if you're looking at the chat. The video goes over the ideas you need to cover, but I'm also gonna go over them here. You can watch a 7-minute intro or 7-minute video where I talk about the ideas and the things you need to know. Let's go show the assignment. And when you're doing an assignment, the biggest thing to know is you should look at the rubric. If you feel like you were graded incorrectly by the rubric, you can ask for your points back. So we're gonna open up, here we are, the rubric. Number 1, first thing is your information. You get 2 points right here for putting your name, your UTK, email, your instructor's name, your section, your class, all that stuff. If you look right here, you just copy paste this right here. You take this, you drop that at the top of your document. Doesn't have to look all fancy. Fill it in. There you go. Good to go. That's how you do that. So we can get the 2 points right there for certain. Don't miss it. Very important to have the 2 points right there. Executive summary. The first thing in the executive summary is outlines what is being researched. The company is identified and the goal for the research is stated. I'd probably do at least 2 sentences right here. Who's your company? What are you doing? What are you researching? You know, it should be clear. It should be direct. The point of an executive summary is you give someone like a 1-pager. It doesn't have to be 1 page because it's like not a huge report. But if you ever have a 1-pager, it's like put everything we need to know on 1 page so I can just see it right here. Boom, 1 page, got it. So the executive summary is the full report. It's not an introduction. A lot of people think, oh, it's an introduction to the report. I will be doing this. I will be finding out this. I'm going to look into this. No, the executive summary is a summary, like a cliff notes of your entire report. So someone could literally take the executive summary, rip it off the report. They could just go down here. Here we go. Here's the executive summary. They go, okay, wait, you got your report and your executive summary. They go, rip. And then they just take your report and they go like that. I don't need the rest of that report. Here's the executive summary. Now, that's all I need. So when you're thinking about what is an executive summary, it should exist on its own. So if they're like, this doesn't tell me anything about what we're doing and who we are and what's going on, well, then it's not a good executive summary. Goal number one of the executive summary, with 1 point, the company is identified, and I did identify the company, walk through who are we, what are we doing, and then what are you researching? I do a sentence on that too. The next thing for the executive summary is going to be key findings. Now, this is where you have to use numeric backing. What is numeric backing? Something like, if we're talking about the Stat 201 grades, Brian was researching Stat 201 students and found that the average for his class was a 76. We need to look at that after we've got our grades in. Yay! So the 76 is the class average. That's a numeric backing. We might use that to make some decisions. I was looking at some data this morning, and I could then talk about, Brian also researched how the Canvas content quizzes aid in students' learning and found that there was a 7-point difference. Notice that 7 points right there is numeric backing. You'll see the numeric backing throughout the reports you're looking at, so you need to bring that into the executive summary. So these are all the important things that were found by the researcher that you're then summarizing. There's another 1 point right here where you go through and you compile some key ideas that have been found and make it very clear. Here's what was found. Here's the numeric backing. They found this. Here's the numeric backing. Don't just copy paste from the data. If you notice, that's where you might get partial credit. If you're just not ingesting and bringing down, condensing it into something more digestible. If you're just copy pasting, you could lose points if you just take a sentence and drag, drop, copy, paste. The point is to understand the report, to be able to read a statistical report, and then to be able to summarize it in a way that other people would get the key details and everything rather than having to read it like you had to do. Sorry. So it's, can you put it into a one-pager, not having a whole big report? And it doesn't have to be 1 page. For a longer report, we might do a 1 page. Executive summary, action item. This is where people usually get confused. When it comes to the action item, it needs to be direct and connected to the results. So you think about with me, looking at the test results and seeing that they're connected to Canvas contents, I need to encourage more people to do the Canvas content, because although I can't show a cause and effect relationship between doing Canvas content and getting good grades, we do have evidence of an association. And since there's evidence of an association, my goal, and Alexander, good to see you there. My goal, because of the evidence of an association, is to increase the rate by which people do Canvas content and then see if that also improves grades for classes. So just thinking through that, like, okay, I saw this, so what is the action item we're going to do? Maybe come up with 1 or 2 of these. If you come up with a big elaborate one, like we're going to be introducing these new assignments, we're going to be tracking the progress with them as they go, and seeing if the new assignments, which is our plan to implement to increase test grades, actually help. So notice how I saw a connection between grades and Canvas content. I quoted it in the numeric backing. And then when I get to my action item at the end of the executive summary, because of the findings that we have, everyone's going to write that now. If I say a phrase, it's like in every report then. You then decide based on those findings what you're going to do. So you make it very direct. Here's what we're going to do. Here's the action we're taking. This is our plan of action. Here we go down to the executive summary format right here. You want 5 to 8 sentences. If they take off for too much, especially if you're my students, let me know. Don't write 2 pages, because the point is to condense it. So if you write like a 5-page executive summary for a 5-page report, it's not a summary anymore, it's just the report. So the point is to be able to condense a report down, give it to someone in a smaller format, more smaller. And I don't grammar. And you want impactful sentences, no fluff. You take out all the fluff, and you give impactful sentences, concise and clear and to the point, unlike me sometimes. So that should be pretty easy right there. Now we get into the future research, and it has new ideas. The future research is not where you just go through and re-summarize the report again. You already have the report. You already have the executive summary. Why would you do a re-summarization of the results at the end? Who's going to read that? The future research is actually included in your 1 page right now. It'd usually be at the end of a report. But this is like the to be continued of a report. I could say, with our suggestions to implement new quizzes, we will be monitoring the new quizzes and how they do. We have a 5-year plan. Everyone's gonna write a 5-year plan now. Don't write what I say. Please don't write exactly what I say. I hate exactly quoting. I want to give a clear example of what I would write, but then don't take what I would write and just put it as your own words. Don't copy me. Think about what would you do. Here, you got your data. Maybe you're working at a pizza place and you see tips are really great on Friday and Saturday? Well, if you're the owner, you might have maybe you might have some of your best work. It depends. Like, why are we getting good tips on Friday and Saturday? Is it the people who are working? Is it the clientele? So then you might actually do some more research on that. That's what I'm thinking now if you're the owner. You might say, well, why are the tips so good on Friday, Saturday? Is it the clientele? Is it the servers I generally have? Do we have that data right now? So we probably need to go and collect that data. You can't really make decisions right now if you don't know where the sources of variation are at. So if you don't have that data, you need to do more research. So that's what a future research would be if I'm the owner of a pizza place. I'm going to say like, well, we saw that tips are higher on Friday, but we don't Saturday, but we don't know why they're higher on Friday, Saturday. We just know more tips Friday, Saturday. So why are we going to really make decisions at this point on what to do because of the higher tips, when the higher tips could be the day of the week, it could be the clientele, it could be the servers we have working those shifts. So I'm really not going to make decisions at this point based on that. Now you might have other decisions, you like maybe other data points or action items in the executive summary, but in the future research, this is where you think about new ideas and things you have not explored yet. So as the owner of the pizza company, I'm going to be going and investigating why we have these higher tips and collecting data on who's working on Friday night. Do we have repeat customers? Do the customers and the servers know each other? Maybe it's a repeat customer-server relationship. All those things right there, very important. And this would be a future research thing because we don't have this data. I can't make decisions on data I don't have. And once again, clear and concise and to the point, 4 to 5 sentences. Once again, if you go a little bit over, if you don't do 4, if you don't do 5, don't make them little sentences like, we saw Friday was high tips. We're going to make decisions on this because Friday, you want to do impactful sentences, clear and concise and to the point, and come up with the new ideas. So this is the executive summary and future research. When you are done with it, it should look something theoretically like this. The executive summary. Maybe even a little bigger than that. That's the exec summary. Future research. Your documents should look. And then here is going to be the who are we, what are we doing? Who are we, what are we doing? Here is going to be the results. What goes at the end right here? The action item. Now those can vary in size, but if you look, the middle portion right there, your results with numeric backing is going to be bigger than the who are we, what are we doing in this report, and the action item down here. Don't make your action item just one little sentence. Make it very clear. I'd probably allocate maybe 2, 4, 2, somewhere like that. Once again, it can differ. There's no exact way to do this, but usually you're going to get more results than you are going to say like who are we and what are we doing. That's pretty easy to state. And the action item, like what are we going to do based on this data, needs to be clear, direct, and data driven. So you will base your action item based on this. This is just the who are we, what are we doing, this is what we found, and this is what we're going to do from what we found. Future research is just one thing with new ideas that go beyond the report. Do not spend a lot of time, if any time at all, restating the report. The new future research, what we are doing, I mean, if anything, you could spend a half sentence saying, you know, well, we found this in the report, so now we're doing this. If you notice, you just jump right into it. It needs to be connected to the report in some way, but it's not the report. I'm not going to say, well, so we found tips were higher on Friday, Saturday. That's what we found in the report. And hey, we're this company, and this is what we're going to do because of the higher Friday and Saturday tips. I know I said we're going to collect more data, but that's research ideas. That's not like a company-based decision. A company-based decision would be like, we're going to put more servers on Friday, Saturday. That's going to be like an action item here versus collecting more data is down here. But then also, don't just say, I'm going to collect more data, be specific. So if you notice, if you just say, I'm going to collect more data, well, that's sure, collect more data, but what on? And then you say, well, we're going to collect data on like who's waiting on the tables, what day of the week it is. And also be very careful. I do want to state this. I need my blinking warning thing. Do not look at anyone else's reports. Do not directly copy. Do not ask people what to do. Do not send anyone your report. So I'm going to send this out. We might just clip this in a segment right here. But if you are looking at someone's report, you are cheating because these are individual assignments. Now, can you talk to your friend? Can you say to your friend, I'm stuck, what do I do? And your friend says, oh, have you thought about this? That's great. We love that. But when you're looking at someone's report, you're reading their assignment. That is their assignment. That's their ideas. But if you ask somebody for help, which is not looking at their report, they're helping you. They're trying to inspire you to come up with ideas. Now, if they tell you what to write, if they're like, well, I wrote this, that's cheating. So just to be very careful, and maybe we'll make this an own segment. I might just clip this because we're trying to make a video on this to make sure people don't cheat. So let's just do a segment on what is cheating. Then I might just put this to the channel. Okay. What is cheating? Let's put this, I'll be able to find this here. This is a segment. They'll do more work. What is cheating? In Stat 201. So when it comes to cheating in Stat 201, we want students to come up with their own ideas, their own words for it, and we don't want them to use anyone else's words. As the syllabus explicitly says, and I'll bring up the syllabus right here, if you have above, and I think it's a 50% matching, we can send you to student conduct just with that. So you don't want to have a 50%. You can see the matching. You don't want to have a high matching. Bringing up the syllabus right here. And here it is right here. Matching, I think it just says high. We give the numbers. Creating visualizations, and it says right here, creating the visualization is developed but using existing written responses where only a few numbers or words are replaced in a common way with high levels of matching is not considered your own work and thus an infraction of the student code of conduct. So do not use anyone else's work. Do not look at anyone's work. Like, that's the thing. How do you get these high levels of matching, but you create your own visualizations? Usually you're looking at someone's work, someone showed you a picture, someone's emailed you a picture, someone sat down next to you, someone said, hey, look at my screen right here. That's how we get these high levels of matching. So let's see right here. I think we said matching elsewhere. There's a bunch of red text where all the cheating stuff is. We can find that, all the red text. Here we go. And right here, sharing or receiving electronic or physical copies of work is against Stat 1 policy. So anytime you're sharing your work with someone, whether it be showing them your screen, saying, hey, look, I did this right here, that is cheating. But here's what's not cheating. I want to make this very clear. What's not cheating, so looking at someone's work and also sending work, receiving work, someone telling you what to write. This is not cheating now. Helping friends come up with ideas. Reading over a friend's work and giving suggestions. Elizabeth, good to see you here. Going to SI. All these things right here, going to SI. SI is never cheating. We approve of everything they do. Unless all of a sudden they start just handing out answer sheets. Please don't do that, SI. I'd have to revoke my we approve of everything they do. If they just start saying, here, do this, they'll be like, well, then we hold SI accountable. But we've never had problems with SI, and we're very thankful for SI. So all this right here, and I would say this, using my videos, using Brian's videos, but try not to directly copy. Like if I say, because of this, we're doing this, watch the video and then try writing the assignment. If you're stuck, come back, watch the video again. It's like if you're writing a book report, you read the book and then you write the report. So if you're thinking about how to do these assignments, you watch the video on it and then you're like, oh, did he? And you just let your own ideas flow. So I want to make this very clear. What is cheating is looking at someone else's work, whether it's on your phone, whether it's a computer next to you, whether the person is dictating their work and saying, do this, write this, or even this, we got to make sure people know this, sitting next to someone and doing the assignment together. That is cheating. This is individual work where everyone's doing their own assignment. So if you sit next to somebody and you both come up with a kind of group assignment, this is not group work. So you can't work together on the assignment, but you can have people help you. So down here, reading over a friend's assignment and giving suggestions is you've already done the work. And your friend's just saying like, hey, I like this, but you could improve this. This is great. We want this. We want your friends to help you. Now, if your friend's like, well, I wrote it this way, so just write it this way, that's not a suggestion. That's just having them copy you. So your friends shouldn't say, well, write it this way because I did it this way. They should say, yeah, you came up with a really cool idea. Now, also be careful. You got to make sure you trust your friends. If your friend is reading over your work to help you, one, if they're not in the class, there should be no issue. If they're in the class and they haven't done the work and they're like, yeah, send me your work, I'll read over it, you have to be very careful. So I know I have up here sending and receiving work, and that goes for people who are in Stat Tool 1, and you do have to be careful because work does get out there. It gets put on sites like Chegg, on Study Blue. Does that even exist anymore? I don't know. The best thing to do is probably, if you want help, is if you have someone with you who's maybe at your place and you say, hey, can you read over this or can I read it to you? That's the best way. So my best way of having someone help you with their work, if you are trying to get someone to help you with their work, is to just read it to them. Maybe you're talking to them and they're in person, so they don't have their computer open next to you. They're like, wait, what was that? What was that? Okay, you wrote it this way? You have to be very careful. And I've had students, and if that were to happen, just to be very clear, if anyone's worried, if it were to happen that you honestly were having a friend help you, and then that friend were to abuse that, then we would get the friend in trouble. You wouldn't be in trouble. Our goal is not to get anyone in trouble, but we don't get people in trouble when they didn't do anything wrong. Do be careful with the sending and receiving work. I want to point that out because this is where I'm sure people have sent work to friends where they thought, hey, nothing's going to come of it, and then that friend sends it to someone else. We've had instances of that where someone sends it to someone who's not in 201, and then that person then sends it to people who are in 201. We're like, well, no. And so you can be held accountable for sending or receiving work. So it's a trust issue. Like, you send your work to your parents. I did that when I was in college. I sent my work to my mom because she's better at English than me. And she would read over it and tell me corrections. Now, my mom's not going to send it. I trust my mom's not going to send it to other students. And I trust my mom. And this was work you'd bring to like a writing center or something, work of that sort, where you're going to need grammar improvements or you say something weird, like it just doesn't make sense. And so with that, you have to make sure you're sending it to someone who's not going to use it in a way that is not going to cause problems, which you never know. Maybe my mom would have done that. Why would you do that, Mom? So the best thing to do is, if you're working on these, I would highly suggest go to SI, use the videos, start early. If you're looking at someone else's work and using that to create your own work, that's cheating. If you are sending work to people and because they're stuck or something, that's cheating. If you're receiving work because you're stuck, that's cheating. Anytime you are looking at someone's assignment and writing yours or using it to create your ideas, that's cheating. So we hit this nebulous zone of where people can help people. I think that's the hard thing for people to understand, because the way we recognize cheating in Stat Tool 1 is you have this high degree of similarity. And the only reason high degrees of similarity will usually exist is because people have copied. So if you write your own report and your friend writes their own report, there should be no reason they're going to have an 80% similarity. But if you write your report and your friend reads your report and then writes their report, that's when you get the high levels of similarity. So if you want people to help you, my best suggestion is sit down with someone who walks you through the ideas, who says things like, well, what would you write here? What is our company? So you think about what you'd need to ask. Let's go back to the assignment and look at that. And how would someone help you through the report? First thing, well, I'd say, hey, go take the stuff Brian said right here and put your name, all this info, just put it in. So there you go, you got that. Next, I'd say, well, who is the company you're working for? Who is it? And write a sentence about that. Just one sentence on who the company is. Write a sentence on what our company is going to do. Did you read the report? Okay, read the report. Now, what is our company going to do? Or like, what are we researching? Excuse me. So I already went to action item. What are we researching? What did they research in the report? And notice how they've already written their report, or maybe they're working through it too at their own time. They're thinking about this, but then don't say, well, I'm going to write this. And they say, oh, that's a good thing. I'll write it too. Don't do that. Everyone should come up with their own ideas. And so the biggest thing is, and I hate getting people in trouble, And it's tougher when people don't understand this, when there's a little bit of ambiguity. And I don't want there to be any ambiguity. The worst thing you can do is to look at someone's report and write your own report, because then you're highly likely to have high matching percentages. The probability you'll have a high matching percentage is next to zero if you don't look at someone's report. And we really don't see that. It's crazy to me that every time I identify 2 or more students who have matching reports, they always know each other, as in they work together. So the students who didn't work together don't have the high matching. And this is out of 1,400 students. So think about this. What is the probability? There's a lot to say on this, and we'll start doing some assignments. What is the probability that with 1,400 students, I'd always match the 2 students who knew each other and worked together? And then they're always like, well, we just worked together, but we came up with our own ideas. It's like, but did you? When I always find the 2 who work together, how is that you came up with your own ideas and you have this matching percentage that just jumps right out? You might be thinking you're coming up with your own ideas, but you're probably taking from each other's reports. And that's where it's like, no, don't read each other's reports, do the reports, and then offer each other suggestions without looking at your report or telling them to directly copy you. This is how we come up with our own ideas and push ourselves further. So I don't want to get anyone in trouble. I'm hoping this assignment, because this one's a big one where there's a lot of issues. Usually this is the one where we send a lot of students to student conduct. Terry and I are going to make a video on this. If you see you have a high matching percentage, I'd probably resubmit. Let me put this. Brian's last suggestion here. Brian's last suggestion. Mark this in the video. My big suggestion. Okay. My biggest suggestion. If you have a high matching percentage, sure, we might get a lot of emails. I'll take them. Instructors, sorry if you get a lot of emails. Do the following. 1, if you included the instructions, delete them. A lot of times we get high matching due to instructions being included, so that it's just a error. We don't type 1 error. Wait, false positive, yeah, type 1 error. That'd be a type 1 error. So if you included the instructions, delete them and resubmit. You'll probably lower. So if you get this high matching percentage, go back, delete the instructions. We don't need instructions. We know what the instructions are. Don't worry, we don't take off. The graders shouldn't take off for instructions. It's just like, oh, they included the instructions. 2, if you are certain you didn't cheat, contact your instructor. 3, so like I'd be like, hey, I got 51%, and they'd be like, oh yeah, the first thing you wrote is basically in the report, and a lot of people are writing that, and it seems like you just copied a sentence from the report, so that's why you're at this high matching percentage, because you and other students just took a sentence from the report, and so a lot of people are taking a sentence. Remember, once again, we're not just copying sentences from the report, but you took a sentence from the report, and people are doing that, so we don't think you cheated with anybody. Things like that happen. Another false positive. Good to contact your instructor before they contact you and say, hey, there's an issue. 3, if you worked with a friend, rewrite your report. So one of you is going to need to sit down and just rewrite the report. And literally, if I had my report next to me, I'd just take my report. No, this sounds crazy. I would just toss out my report. I think I just got that in the trash can. I would just take my report and toss it out. It's not worth a trip to student conduct. It might be a false positive. We might not actually contact you, but like just rewrite it at this point. Especially if you contact your instructor and they're like, yeah, there seems to be an issue with your report. It's really matching someone else's at a high percentage. Oh, rewrite your report. Say, I'm sorry, I don't want that report to be, you know, it's before the due date. I'm just checking with you. I want to get this in the right way. We'll say, yeah, every instructor should. If you've contacted us before we contact you because you're worried about something, then no instructor should get you in trouble, because you're obviously taking the steps to be like, I want to do this right, and I'll put in the work. I got time. Does this look like a problem? If it is a problem, it's going to be fixed, not a problem. I don't like sending students to student conduct. It's one, I don't like doing it, and two, it's more work for me, so it's bad. And yeah, so please, my biggest suggestion right here is delete the instructions, don't include those, we never need them. Two, if you're certain you didn't cheat, contact your instructor immediately, and they might even tell you like, actually there is a problem, and if there is, tell them, hey, I'll resubmit it. And if you worked with a friend, if you're like, well, I kind of worked with this person, and I don't know, they said, hey, read this, and it got in my head, and I kind of reworded their sentence a little bit, changed a few words here and there, then please. Might clip this. We're going to make some funny videos, I hope, but due date's approaching, so I wanted to put this in this video. Okay, let's go back to the main screen. Elizabeth, are you still here? Elizabeth? We're going to do some chapter 14, I think. We can do the full chapter 14 homework. Alexander, what do you want to do, Alexander? Talk about the project. Terry should know the curve. What are we going for? A 20-point curve, right, Justin? Terry should know the curve here. I hope today. I was kind of hoping to release it with the curve. No, I need to go look at the grades. Let's do that. Justin, good to see you here. I'm going to start off, so I was a little bit late today. Got a digital faculty consultant meeting, so I'll send that out as a reminder. So 2 p.m. is when I'll be starting today. I'm in an online meeting. Let me go look at the grades. We probably have, what did we have before? 67. So we probably got 8 points. So we probably have a 76 average. I say 76 average. What do you say in the chat? Any other votes in the chat? We'll throw some points. 76 average, I say. Any other guesses? 76, I say. If anyone takes guesses besides me. I'd be sad if I know it. I usually know about how many points we get on the written. There's written portions on exam 3. 76. Quiz statistics. Here we go. I say 76. Just so you know, it's loading. Where's my Marvel? Oh, what? I don't have the screen share on anymore. Background on that. Okay, no, kidding. Reloading right now. I say 76. 76. The data analytics due tomorrow. 75. I was close. Are we able to do it with what we've learned Tuesday? Yeah. The data analytics is future research executive summary. Yeah, so there's no, it's just a writing one. This distribution is extremely what? Extremely what? You look at that monster, man. Very what? There's a modal area here and a smaller modal area here and a modal area very left skew. Very left skew. Great job, Alexander, right there. So when I was right, I thought it'd be 76, which is all right. I think we got about 8 points. That's all right. That's all good. I mean, it's C average. I'll take it. We've done worse. I'm all right with that. But I always want the highest grades possible. I'm always going for high grades on the lesson. Everything. Place questions. We're going to start up some quiz right here. And we'll hear from Terry. We'll do the homework first. Let's start up chapter 14 homework. Chapter 14 homework. All right. Here we are with chapter 14 homework. So check out this video here if you're stuck on the homework. Put the timestamp in here. Chapter Stats 201, chapter 14 homework. Okay, with chapter 14 homework right here, we are first finding the critical values of the t. Probably one of my favorite questions. The z stars, which we use for confidence intervals, are always known. Now, when you think about what a z star or t star is, it is used when we talk about how confident we are. So in a 1 proportion z interval, which is p hat plus or minus z star, we can do better than that, plus or minus z star, p hat, q hat over n square root. Then we have now for this chapter y bar plus or minus t star n minus 1 degrees of freedom s over square root of n. So these right here, and with the star, denote how confident you are. Now the t is always bigger than the z. And there's a really great site. I do love RT applet. I'll pin RT applet. But the visualization on it is actually more accurate. And this one does my Mr. T thing when we do it. Let me go to statdistributions.com. And you're going to see a slightly different site, but then I'll open up ours too. So the normal is where we get our z's. And we go to the between right here. So we'll go to the in-between. I think this is the in-between right here. And we'll go to 90%. And that is a 90% confidence interval, or a z star, when we use the 1 proportion z. The t has degrees of freedom. We have to enter in the degrees of freedom right here. Now, as you get more degrees of freedom, the t goes into the normal. Notice low degrees of freedom, flattened out. High degrees of freedom, more like the normal. So what's really great is I love guessing these ones. They're fun to guess because 90% confidence with 11 degrees of freedom should be about, this is a tough one though, 1.856, sure. And, oh, I get one more guess. There, I got it. How'd I know that? So the t becomes the z with more degrees of freedom. The z score for a 90% confidence interval, if you memorize it, is 1.645. The t always has to be further out because it's more smashed down. Mr. T says, ooh, smashes it down. So the t is further out than the z in all instances. So if the z is 1.645, because that's what the z is always the same. There's no different z's. 90% z is 1.645. 95 is 1.96. Probably a lot of people did the last assignment and know that from 1.96, 1.96, 95% confident. The t will always be further out, but it approaches the z as degrees of freedom increase. Degrees of freedom for the one sample t is n minus 1. So this came from a sample size of 15. These are things you need to know about the t, like it has with the degrees of freedom, and n minus 1 are the degrees of freedom. So now we go right here, and if we want to know the answer without doing memorizing or guessing, we go to the t applet on the screen. So go to the pinned link on the screen. Here's the pinned link, and here's how to get the answer to the question if you don't memorize or guess it. You go here to the t applet, and let's open up the t applet that we have on the screen. It's this one. And then on the t applet, you enter in the degrees of freedom. So the degrees of freedom here, you notice, are 14. You click between, and then you enter in the percent confidence, and the t is 1 point. And we'll make this on the screen at the same time. There we go. Oh, trying to get it all nice and purty right here. There we go. And now there's the t value right there, 1.76. Check answer, good to go. Same thing here, 88 degrees of freedom. This is going to approach 1.96. It's going to be very close to it. It's going to be 1.98 or 1.9. They have to change the degrees of freedom up here to 88. And notice as we go towards 88, it goes towards 1.96. And I said, see, I was off. It's, there we go. Do another decimal or two. It's getting very close to it. Yeah, I would have accepted this. Yeah, it did. And so I love this question. I think it's a great question, understanding how to use a t-applet between. So we can guess this one is like 2.04. There we go. And to check the answer, we go over here, 95% confidence. And notice as we go down, it goes, the t gets bigger because at lower degrees of freedom, the t is bigger. So, wow, it was very nice on that guess. 90% confident is 1.645 if you have a ton of degrees of freedom. So usually a lot of freedom is around 100, where it's similar to it. So it's going to be biggerish. Once again, you can just type in the number and get the answer. It's going to be like 1.70. Close enough. And 1.70 would have probably got it. And computers and software will do this for you. Once again, it's just a fun question to see if you understand how it works, that the t will be bigger than the z. And I should remember that last one. I think this has less degrees of freedom than the last one. There we go. And that's 1.7. Oops, 90%, 88. Oh, it's more degrees of freedom. So yeah, it's a good bit. There we go. And once again, 88 degrees of freedom, just put in the number 88 right there, and there you go. We're getting close enough with our guesses. This is the t-applet for the t-distribution, which is used in t-confidence intervals and t-tests. Right there, you were just solving this with the n-1 degrees of freedom. That's what we were just solving right there, used to make a t-interval or to do a t-test, coming up there in the next chapter. So I just like that question a lot. It's fun. It's a guessing game. Okay, describe the shape, center, and spread of T models. Well, we just saw it. So shape becomes closer to the normal. Oh, as degrees of freedom increase. Literally what we are doing. So we go back to here, and as we increase the degrees of freedom, going from 1 to higher degrees of freedom, it becomes more normal. And notice the spread at the bottom. If you watch the spread also, going from 1, look, it goes from -10 to 10. As degrees of freedom increase, the spread is getting smaller, and it becomes more like the normal. So let's see if it says it right here. It gets closer to the normal, the center did not change, and the spread becomes more narrow. There we go. That is everything right there. And once again, if you want to see it again visually right here, the center is at 0, go to degrees of freedom 1, center is at 0, start increasing, center does not change, spread gets smaller, and it becomes more like the normal, with numbers like 1.96 approaching as you go towards infinite degrees of freedom. It never truly becomes the normal, but as degrees of freedom increase, the T becomes more normal. The housing market has slowly recovered from the economic crisis of 2008. Recently, in one large company, realtors randomly selected 29 bids, that's condition 1, and sample size 29 from potential buyers to estimate the average the average loss in home value. The sample showed the average was this, that's the sample mean, with a standard deviation of this, that's the sample standard deviation. Now, as Leo famously said,
notation, brother.
Notation, brother. Before doing any of these questions, I want you to see how I solve these questions, because that's key to learning the material. The first thing I do right here is I always mark notation. The reason I always mark notation is because notation shows us what we need to do and the steps for the problem. So when we see 29 bids, that is the sample size. When we see the average loss right here is going to be y bar. When we see standard deviation, that's a standard deviation for a quantitative, so that's S. That's not SDP hat, that's not SDY bar. SDP hat is the standard deviation of the sampling distribution of the sample proportion. SDY bar is the standard deviation of the sampling distribution of the sample mean. This just says this data had a mean of this and a standard deviation of this. That's Y bar, sample mean, and S, sample standard deviation. And from here, we have everything we need. Now, since we're doing quantitative data, and I want to point to another video, one of my favorite videos right here, I think it's under review 3. So if you go to the review 3 page, I have a video going over all the conditions for all the tests. So right here, we're going to scroll down a little bit, and more material will appear on the review page. First word I say is So if you go all the way over here to the end of the video, you can see what I write out. And we are doing a T interval right here. A T interval has a randomization, which means we randomly select the data. Less than 10% is selected, and then we pause when we get here. Since we're doing quantitative, we need the data to be nearly normal. There are 3 conditions. Success failure is only for categorical data. Quantitative data will do nearly normal, and this is the chi-square test of independence, chapter 19. So check out this video right here and the other videos, especially in this playlist, going over hypothesis testing, t-test, 2-sample t-test, and I want to point these out because in these videos, I go through and mark every bit of notation in the problem. I don't think I make any errors. Everything is marked. I go through and show each step and how to do the test, and it's basically a mini lecture, and I don't think I make any errors. Hopefully I don't. But you basically have a mini lecture here talking about the topics on test 3. Notation is going to be very important for these problems. So if you look at what we have to do with this one, we have to figure out, are the conditions met? Condition 1, was it random? Well, it says it was random. Condition 2, less than 10%. Well, I assume 29 homes or bids is less than 10% of all bids. Safe to assume. Condition 3, pause, quantitative data. It's not the condition, but we're making sure we use the right one because we're like, What is condition 3? Nearly normal. No longer the large enough n condition. The large enough n condition was for the sampling distribution of the sample mean. It's now wrapped up into the nearly normal condition, which basically, and I'll abbreviate it right now, states that the data is unimodal symmetric. Hence why I drew the distributions on it. If you look at my drawing, when talking about it, I drew some unimodal symmetric distributions on. Proportion. We'll come back. We'll do that. So nearly normal. That is our. We want. I go into more detail on it right there, talking about what the nearly normal is. But the nearly normal basically is unimodal symmetric data, or reason to believe that via large enough n, which now becomes part of the nearly normal. So let's go look at the conditions. Condition 1, random, randomly selected data. And the independent is basically saying that independent would mean random. It's large enough to have a sample size that's approximately normal. So they're using large enough to choose the nearly normal. So approximately normal means nearly normal. Check the independence condition with the randomization. Cool. Check the sample size assumption by, no, not 10 successes, 10 failures. Nope. That is wrong kind of data. The data is assumed to be independent and from normal. True. Check the independence with the, nope. This has got to be this one by, yep. So let's read over the answer. The data are assumed to be independent. True. Check the independence with the randomization. Check the normal with the nearly normal. Perfect. Using a histogram, which is literally, check it with a histogram. Wait, what? That's right there. A histogram. You can look at a histogram and see if it's unimodal symmetric. Now we get into where people get stuck. Now you have to solve the math. To solve the math right here, we go back and we write out the equation. The equation is y bar plus or minus t star with n minus 1 degrees of freedom. That's a subscript, not a multiply by, s over square root of n. So when we do this now, we have to know what percent confident, 90% confident. Now we have to go to the t-applet to get the t for 90% confident. We have to know the degrees of freedom, which I didn't mark. So anytime you go to the t-applet, you have to know 3 things. On the t-applet, 1, what were your degrees of freedom? Degrees of freedom are n minus 1. My problem had 23 sample size. Degrees of freedom are 22. This is for a 1 sample t, degrees of freedom n minus 1. 2, click between, because confidence intervals are the area between the upper and the lower. 3, your percent confidence. So enter these things in order if you want. Your degrees of freedom for a 1 sample t is n minus 1, sample size minus 1. Your percent confidence, and then between, because it makes the confidence interval going from the lower to the upper. Our t-score is 1.72. So we have now found a t for 90% confident with n minus 1 degrees of freedom equals to 1.72. Degrees of freedom right here was 22 because, oh no, they're 28. Oh, I wish someone was here to tell me. They're 28, which means this is probably going to be closer to the actual z-score. So let's put this as a guess. And they're 28 degrees of freedom. Got to be careful. We just changed this to 28, and there it is. Did I guess it? I did. There we go. Because it just gets closer to the z. It'll go towards 1.645 as the degrees of freedom increase. So I just did that on purpose. I didn't do it on purpose. I don't know where I got 23. Oh, that's the Trip Hammer Road problem. So the sample mean is 8861 plus or minus 1.70. That's the t right there. S is 1,155. Sample size is square root 29. A little color coding here to help out. Try doing this yourself. Try color coding the work. All these problems are going to be very repetitive, and these go for the quiz too. They're just practice. There's degrees of freedom. That's not a good color for that. S, standard deviation. Sample mean. Sample mean right here. Sample mean. And we have sample size. Oh, I think it's got it. Oh, sample size. And degrees of freedom used for calculation purposes to figure out the shape of the t right there. So now we go in and we solve the problem. 29 square root and 1155 divided by this. And that is the standard error. So the standard error is 214. We're also going to mark that here. The standard error of y bar, which is variation in the sample mean, is 214. And now we multiply that by the t to get the margin of error. So times 1.70. There's the margin of error. So MOE 364. and we'll carry decimal here in a moment, equals 364. Hey, what's up, Elizabeth? Good to see you here. How do you get the T again? Go to the T applet. Yep. Do you see the T applet link right here? So you want to go to the T applet link, and in the T applet link, put in your degrees of freedom, your area, and then the between. I have a question about data analytics of 5. When you get a chance to summary over the entire report, do we pick one section over the entire report, Arden? So you can summarize, you can pick parts out of it, don't copy paste, but it's the entire report right there. So, and then mention key things that are important. Like, 3 or 4 key details that you found to be important. So kind of reading through it, taking the big key ideas. Arden, good question right there. And I covered some of it at the start. Check out that at the start of this video. And I covered don't cheat, which I don't think anyone here is going to cheat. I hope not. So you're welcome, Arden. Thank you so much. 8861 plus or minus 364 and 0.61. And then the upper and the lower is going to be 922561. I forgot the 5. You can actually subtract twice because you go back through the center of the interval. 849639. Oh, which part are you lost on? 849. Can you go over degrees of freedom with the T? Yeah. 39. So the degrees of freedom, what's the formula for degrees of freedom? What is the formula for degrees of freedom? Good to see you, Blakely. How do we get degrees of freedom? If you notice, my sample size here is 29. So how do you get degrees? What is the formula for degrees of freedom? I'll circle it. N minus 1. Yep. So sample size is 29. So degrees of freedom for the one sample T is N minus 1. So it'll be 28. Let me know what you're stuck on. Since you're here, we help out. I mean, like, that's what we do. But, like, the videos are meant especially for the people here watching. So the sample size is 29. The degrees of freedom are 28. Is that good right there? So you just identify in the problem, sample size 29, degrees of freedom 28. Yep. And what's the, keep going, let me know what you're working on. And so then you take everything right here and you plug it in. I've got it color coded right now. I did some additional showing, like their standard error white bar is this, the margin of error is this, because that's these two multiplied together. It didn't ask me all these things. I'm just making sure I know margin of error is everything after the plus or minus. The standard error is S over square root of N. And then to get the T, you have to go to the T applet to get it. Or, yeah, kind of a general idea via memorization. On the test, we'd give it to you. The test, we'd give you the T. So now we go here and put this over on the other screen. We enter in the numbers. Hopefully we didn't make an error. Round to the nearest whole number. That's nice of them. 8496. And then 9226. That should be right. Yay! Oh, that's it. Good question. The hardest part for people a lot of times is finding the T, which requires going to the T applet. So to find the T, you have to go to the T applet. Once again, you need to go to the T applet here. You need to enter in your degrees of freedom. Mine were 28. You need to enter in the percent confident you were. Mine was 90% confident, and then click between. So those are the 3 things you need to enter in to find your T. It's different from the Z where it has degrees of freedom. Make sure you enter in how confident you were, what were your degrees of freedom, and then click between. And then this will give you the T, which is used in the formula right here. There's the T right there, found by entering the degrees of freedom, and it's at 90% confident. So make sure to check your problem. Not all of them are 95% confident. That one was 90% confident. Okay. Next question. Theory question, it looks like. It says the housing market, same sort of idea with a mean of this, a standard deviation of this. Suppose a 95% confidence interval was created. Suppose the standard deviation had been this instead of this. Standard deviation is a measurement of variation in data. So if you look at the formula we've written out today, which is this one right here, the standard deviation, it's saying, what if that was bigger? And just to be clear, this is the standard deviation. So that's just standard deviation of the sample data. This right here That whole quantity is the standard error of y bar. That is called the standard error of y bar. It's not the standard deviation of y bar because that comes from the truth. The sigma over square root of n is the standard deviation of y bar. The small difference here is the truth is used in a standard deviation calculation, where the estimate, the standard deviation, is used in the standard error calculation. And so now we have right here, it says, what if the standard deviation was bigger? Well, if the standard deviation was bigger, that would make this quantity right here the margin of error bigger, because you're just putting a bigger number into this equation. You could even go right here and rewrite it to be the following. You could put 1 right here, and you could put s right there. And if s is increasing, you're just multiplying this whole thing by it. So just rewriting it, I don't suggest doing that, but it just maybe makes more sense if you think, well, you're multiplying by a bigger number, this whole quantity here, which is the margin of error, and you would just be making the margin of error bigger. That's how we classically write it right there. So a larger standard deviation increases the width of the confidence interval by increasing the margin of error. A class may suggest that the margin of error in this interval can be reduced if the level of confidence were changed from 90 to 95. No, I don't agree with them. Because level of confidence is controlled by the t. So when you go to the interval right here, the margin of error right here, the t is how confident we are. This is confidence level right here, confidence level. And if we increase confidence level, we increase t. This can be seen right here in the applet. By increasing the confidence level, you increase the interval because you get a bigger t. By decreasing, you would make a smaller interval because you're less confident the truth is contained in the interval. I would definitely disagree with that classmate. I'd say, nah, if you increase your confidence, you're going to get a bigger interval. So no, because the width of the confidence interval does, nope. No, because lower confidence would make the interval, no, because the lower, wait. Oh, no, wait, they're saying if you go to 90 instead of 95, that would decrease the margin of error? Yeah, it's going to be reduced? Yeah, lower confidence makes it tighter. That's true. I thought they were going from 90 to 95, which would make it wider, but they're going to change it to 90 from 95. A little confusing right there, because I was like, none of these answers make sense. Yes, because a lower confidence means a narrower interval. And just to show that again, let's go back here to your classic 95, and they're saying they're going to go down to 90, and that would lower the t, which makes the interval smaller via the mathematics right here. So if you have a lower t, you're less confident because the t is directly connected to your level of confidence. That is how we decide the t, and why we put a star on it to denote how confident we are. Okay, next one. It's all theory. Theory stuff. Instead of changing the level of confidence, would it be more statistically appropriate to draw a bigger sample? You bet. We don't usually manipulate the level of confidence. Classically, statisticians build 95% confidence intervals. We just do that. It's our thing. We build 95% confidence intervals. So you don't really want to manipulate your confidence because you'd be like, well, let's just make a 10% interval and then it'll be really, really precise. And that's a word you should know. Precise means tighter interval. So to make precise intervals, take these notes if you don't have them. You can either lower the confidence to get more precise, but then you're less confident, or you can increase sample size. So a larger sample would be a better idea. A larger sample would reduce the standard error of the mean and make the confidence interval narrower. It would be more statistically appropriate. That is true. And what they're explaining to you right here is, remember we said previously that the standard error quantity is this right here. So if you were to go here and increase the sample size, you would be dividing by a bigger number, and thus the standard error would go down. The standard error quantity, and I've got both things in a blue box right there, so let's change the color coding a little bit. If you increase the sample size right here, you will make the standard error go down. The standard error of y bar is everything in this box. And by decreasing the standard error, you are multiplying by a smaller number, thus having a smaller margin of error. Also, if you want to think theoretically on this, if you get a larger sample, you'd have a better understanding. Better understanding means narrower interval. So it makes sense theoretically that more data means a better understanding. And better understanding means tighter. Now, it doesn't mean more confident. It just means you have a better estimate. It's not mean you're more confident in the interval. Confidence is only controlled by the t. So be careful on the words right there. Better estimate does not mean more confident. It just means more precise due to larger sample size. Here we have a question about what are the degrees of freedom. Alexander, good to see you. Can you get this one, Alexander, for 1,000 points in the chat? And I got to change the buttons because they have the wrong thing on them. For 1,000 points. If the sample size is, I think it said 15, what are the degrees of freedom? If the sample size is 15, what are the degrees of freedom? The sample size is 15 for a one sample t. Does it even say one sample t? Oh, it does, because interval for the population mean, which is a one sample t. Because it depends on what test we're doing. It's 14. Boom, you know it right there. I said 1,000 points, did I? Just testing out the new buttons. 14, n minus 1, we got it. And then they show you the formula. Another one right here, we get an interval. Justin, good to see you right there. And do remember, for the one sample t, it's n minus 1. For the two sample t, the formula is what? Do I still have that on the screen? For the two sample t, there it is. The formula is what? Does anyone remember from class? Good to see you, Catalina, right there. The one sample t is n minus 1. The two sample t is what? The two sample t, which you can solve with the applet. Do you remember from yesterday class? For 1,000 points. Here you can solve it right here. The two sample t is what? Ready for this? How do you think you can memorize it? Remember, the two sample t, as I misspell right there, the formula is too complicated. It's too complicated. It's the two sample t. This is when you're comparing the difference in two means. The formula is too complicated. We'll never do this formula by hand. I highly suggest just using an app or something to do it, or output from statistical software. We're not going to do this formula by hand. The two sample t is too complicated when it comes to the degrees of freedom. It can just be solved using an app like this that does it for you. I set through all my alarms in class today. Oh, you're welcome, Brooklyn. Good to hear that. We'll throw you 1,000 points right here. Yep. And so if you have questions, just let me know. We're working through the assignment right here. Check out, we got the video marked, and we're just kind of going over the theory too on how to do this since we're doing the full homework. So big shout outs to everyone watching this in the future or right now. I'll get an announcer. Hey, everybody, how we doing? And let's go check right now. Here's the problem. Now, once again, you know it, you love it.
Notation, brother.
Gotta have some new memes for our class. We've got right here the standard deviation. We've got the average loss. We've got 95% confidence. We've got a sample size of 37 bids. And then we have the upper and the lower of the interval down here. So this is the upper or the lower and the upper. This is going to be y bar because it's the sample mean, sample standard deviation. And then we have the sample size over there. And then we have the t-score related to it. And once we know sample size is 37, for 1,000 points, what do I find if I know sample size is 37 and I'm doing a one sample t? Mr. T is mean if you're doing drugs. Don't forget that. Mr. T is mean if you're doing drugs. So this is the mean, and we use the t with the mean. So what can we find when we're doing a t distribution? If I know n is 37, we just did a problem on this. What else should I find if I know n is 37 and I'm doing t's? Doing the t distribution to look at a confidence interval for the mean. Degrees of freedom. Justin, man, on fire right there with some degrees of freedom. We need like a, rah! Let me go, see if I get copyright claimed here. We're doing this right now. We're doing this right now. We're doing it live. As a famous man once said, we're doing it live. Oh, here's my notes. Okay. Oh, it'd be harder for me. So I'll do it right after this assignment. I'm going to have a bald eagle scream. Wah! Which one of these has to go away? I don't use sound of silence much anymore. This doesn't work. Degrees of freedom, we're going to have the bald eagle scream. We're doing it. Okay. So what's the question asked? I don't know. Let's go find out. Choose the correct, always got to interpret it. Here's the thing though. A lot of people on the test don't know how to interpret confidence intervals. When it comes to interpreting a confidence interval, you have to remember the proper wording of interpretation, which is going to be, I guess I'll write it out here. I am blank % confident that the true blank. Do you use the t to find the critical values? Yep. Yep. Is contained in the interval blank to blank. Can anyone do this? We're trying to figure out the true average home loss value. Go ahead and try to figure this out while I look for bald eagle scream really quickly. Interpret this interval. There's the lower and the upper. I am blank % confident that the true blank. Try to do it. 1,000 points on the line. You will be doing this on the final for 8 points. 1 is 99% confident. Is that what it says on the question? Oh, I think I put the lower bound, upper bound. Yep. Notice they say 1 is, Alexander, I gotta tell you the 1,000. So notice right here, yeah. I am 99 or 95% confident. We'll mark it right here. So let's mark this up so it's easier to see. And what you would put right here. Very clearly, and great job, Alexander, right there. Here's the lower, here's the upper. The context is true average home loss. And the confidence level is 95. So notice how it goes. I am 95% confident that the true average home loss in value, whenever the economic crisis happened, is contained in the interval 8,015 to 9,949. Does that make sense? Nice job, Catalina. More points right there. But not true proportion, though. Not true proportion. This is a common mistake because proportion is the first one we do. It won't always be true proportion. Catalina is still 1,000 points, but on the test, it won't always be true proportion. That's the first one we learned. So a lot of people write true proportion. This is why I don't write true proportion right here. This one's true average home loss because we're doing Mr. T. Mr. T is mean because he deals with quantitative data. That's why he's mean. What do we put after true? The true average home loss. Right here where I have this highlighted, I am 95% confident that the true average home loss in value during the crisis is contained in the interval blank to blank, and then use this right here. Does that make sense? So we've got it color coded up there. I am 95% confident that the true average home loss in value is contained in the interval. So be careful. Quantitative is average, categorical is proportions. Sometimes we do two sample T's, difference in means. Really good stuff, really good question. Interpretation right here. Let's go do it. Lots of points in the chat today. I am. 1 is 99% confident the average home loss value is. Is that right? True loss. What's the difference? 1 is 95% confident the true average lost home value is between. Oh, the home sampled. It's not the home sampled. It's the one without the samples, exactly, because it's for the truth for all data. It's not. Well, that was a short question. We don't make proclamations of truth about sample data. We know the truth for the sample data. Really good question. Well, it shows it. If you didn't know the sample mean, you could average these numbers right here. So yeah, I could give you a lot of questions on that one, like how to find the margin of error, which is right here. I do like this question a lot. It's an interpretation question. So with this one right here, it's how do we actually interpret it? So the first thing I would do, another 1,000 points right here, is interpret the interval. So how would you properly interpret the interval? That's the same one I just did. So the interval goes from 45 to 67 pounds, and we're trying to estimate the true weight gain of pounds on average, the true average weight gain. So try doing it. I know this is practice, practice, practice. When you get to the test, it's easy. I am blank % confident that the true blank is contained in the interval blank to blank. So what would it be? Remember, we're trying to estimate weight gain of cows. I am 95% confident that the true average weight gain in cows is. Alexander, great job. You're getting it down right there. If you notice, it's not for an individual cow. So this is incorrect because it's about an individual cow. They say that it's about the truth. The confidence interval is for the population mean, not for individual cows in the study. That looks right to me. The next one says 1 is 95% sure that a cow, once again, a singular cow, not the cows, not all cows. The confidence interval estimates, the confidence interval is not for individual cows again. Not about a cow, it's about I am 95% confident of the true weight gain of cows. 1 is 95% sure that the average weight gain among the cows in the study. How much weight did the cows gain in the study? Does anyone know how much weight gain the cows had in the study? How much weight gain did the cows have in the study, which is the sample mean? How much weight gain did the cows have in the study? We don't make intervals to estimate the sample. We know what the sample is. So we're not 95% confident the sample mean is this. We know what the sample mean is. We're trying to estimate the true mean, mu, not y bar. So one knows the average weight gain of the cows in the study is this. We don't know what the truth for all cows will be. We don't know mu. So we don't know that. The average weight gain of cows fed this supplement will be between this. The average weight gain of cows fed this no. Let me think. This one's iffy. The average weight gain of all cows does. Oh, yeah, that's okay. That's right. So, yeah. So the truth is the truth. It's a constant value that the confidence interval tries to encapsulate. I don't like this theoretical one because this is very close. When they say average right here, they should have said true weight gain. They should have made that more clear. So they should have said the true weight gain of studies will be contained in the interval this percent of time. No. And they could have made their question more clear on that. That one, I won't comment so much on the theory. It's incorrect. Great job, Savannah, right there. Because the truth doesn't change. It's like saying the truth is 30. Well, then the truth is just that. It is what it is. Truth doesn't change. If the supplement were tested on another sample of cows, there's a 95% chance that their average weight gain will be between this and this. Also seems iffy. It doesn't seem like we're saying with our I am 95% confident. The interpretation is incorrect. There's 95% chance on their study. We'll have within, yeah, it should be within the truth. Maybe 2 standard deviations of the truth. That should be right. I'm a little worried. I think it's that theory. Yeah, it is. So that actually gets to sampling distributions, because notice how they're saying standard deviation here, not standard error. Because if we knew the truth, all samples, 95% of samples would be within 2 standard deviations of the truth. They're blending chapters. Not a big fan of it. They're trying, well, okay, they're trying to make you understand that the truth would have standard deviations from it, standard deviations of the mean, within 2 standards of the true mean. Yeah, that's true. So that is a tough last one. But the thing I want to point out with that last one is it doesn't follow our format. So the format is, I am 95% confident that the true weight gain of cows is contained in the interval blank to blank. So the biggest thing is I thought it was wrong because it doesn't follow my format. Now you can say one is or we are. There's small changes that can be made that are fine. I like to say I am. It's just the way I was taught to say it. But if you start seeing things that really deviate, they're probably not giving you a correct statement. That probably is a small error. That's why also I suggest people write this out. It's not that you have to write this. It's just that if you change up things, you might break something. So this is best just to, I don't know, there's the answer, how to do it. Next one, biology class conducts a bird count every week during the semester using the number of species counted each week. A student finds a 95% confidence interval from 16.34 to 18.69 for the mean number of species counted. Knowing the species have to be whole numbers, the student reports 95% confidence of 16, 17, or 18. Comment on this report. Now, this is a common error when it comes to the mean. If I tell you the average person has 2.2 kids, is there anybody with 2.2 kids? Yes or no for 500 points? Is there anybody with 2.2 kids? No. But the mean can be averages. Yeah. We start off, check out the start of this. It's around 10 minutes in. I went over right there, Scholar, we can go back to. I might do more quiz stuff, but check out the section in the video. It's 1 minute in, I start talking about it. If you go to the very start of this video, check out that and let me know if you have questions. So while the mean number of species, the confidence interval only estimates the sample mean. No, the confidence interval estimates the population mean. The population mean does not have to be whole numbers. Yeah. A lot of people are like, but wait, it can't be decimals. Like, well, it's an average. It's on average. Based on meteorological data, a local TV weather forecast estimates the region's average snowfall will be 23 inches with a margin of error of 4. Assuming a 95% confidence interval, how would we interpret this? Okay, I want you to do it again for 1,000 points. Alexander's on fire right here. How do we interpret the interval? How would we interpret the interval? For 1,000 points, interpret the interval. Remember, this is all test 3 stuff. Don't read their answers, write your answer out. And then we're going to compare it to their answers. The proper interpretation of the interval. What is the proper interpretation of the interval? Always write out your interval. And you notice we can grab the question here while you're doing this. And write it out. Trying to estimate the true average snowfall. Don't worry how many times you write this. It just means you're going to be writing it quicker on the test. What? Okay. The interval can be written as 23 plus or minus 4. That'd be 19 to 27. There. I am 95% confident that the true average winter snowfall is contained in the interval blank to blank. Great job right there. So you notice we get the lower and the upper by doing the estimate plus or minus the margin of error. Do know that the first number is your estimate. Then you get the plus or minus the margin of error, which is given by this right here. And there's the estimate, which is y bar, and this is the MOE. Right here, we get the context, the average winter snowfall for this region, and it said 95% confident. And look at that. I am 95% confident that the true average winter snowfall for this region is contained in the interval 19 to 27 inches. Great job, Savannah, right there. And now we go and check it out. During the past 95 of 100 winters, we're talking about the true average. The intervals for the population mean, not for individual winters. No, we're trying to estimate the true mean. There's a 95% chance that the region will get between... No, it's not about this winter, it's about all winters, the average. It's not about this winter. Not predicting for individual winters. But the population mean snowfall and the true mean. This is the true mean, the population mean. Not predicting the snowfall for individual winters. That sounds right. There will be between 19 to 27 inches of snow on the ground for 95% of winter days. It's not about days. Catherine, good to see you here. So it's not about days. It's about the true average snowfall for all winters, or like in this region. The intervals for predicting the average snowfall, it's not for next winter. The confidence interval only estimates what will happen. No, not for the sample. So this one looks correct. Just by virtue of process elimination, the confidence interval was based on a sample of snowfalls for several years, not the amount of snowfall on the ground. Yeah, it's not what they're trying to estimate. Residents can be 95% sure that the area's average snowfall is between... Ooh, wait a minute. How about we read residents can what? Wait, change residents right there. I see something right here. Change residents to what? Seeing something. Change residents to what? Go away. Change residents to what? You see it? We can see it too. I am. Nice job. 1,000 points in the chat. So we changed the residents to I am. What should we change sure to? What should we change sure to? Change residents to I am. And yeah, change sure to confident. So wait a minute. All of a sudden now, I am. Oh my gosh. Wow. I am 95% confident the area's average snowfall is between blank to blank. What? Because the residents are people too. I'm a person. I think that looks pretty darn correct right there. There you go. I am. Nice job right there. Residents can be 95% confident that the average snowfall during the past century. No, we know what that was. It's the center of the interval. The estimate creating the truth estimate. There we go. Yeah. So we know what it was during the past century. We don't have to estimate what it was. We have the data to know that what it was. We're trying to estimate the truth for all winters. So really, really good question. It's very nuanced, but once again, writing it out, and great job, Samantha, right there. Writing it out is the key to these. If you can write these out, you do better. Are there questions on the quiz? We just did the full homework. Took a little while right there, but that's all right. It was good practice. Hopefully, it's like kind of like a mini lecture if you watch this, because we went through everything. We did each problem like thoroughly, did all the work right there. What questions be on AI Panel of Voices webinar? Oh my God. Let's start the quiz right here. I don't think there's that many questions on the quiz. Whoa. Okay. Is this the right quiz? Okay. What quiz questions are there? Drop the quiz questions in the chat. A lot of quiz questions. So we could do quiz finding critical T's. Do that. Quiz question finding critical T's. Drop a question if you have it. 11933. Stat tool 1, chapter 14. Finding critical T's. Okay. So when you find a critical t right here, you have to go to the t applet. So with the t applet, all you do is 3 steps. Step 1 on the t applet, and let's write it out right here, is going to be find your degrees of freedom. And it's going to be n minus 1, capital, lowercase, 1 sample t's, which is all we've learned right now. 1 sample t test / t interval. And it's too complicated for the 2 sample t. So what I'm saying right here is when you go to the applet, right now we will enter in n minus 1 degrees of freedom. These problems tell us the degrees of freedom. But you just go up here, you enter in, like my problem says right here, 24 degrees of freedom. So I enter in 24. If it gave a sample size like 25, the degrees of freedom would be 24. So if you know the sample size for a 1 sample t, which is the current chapter we're covering, the formula is n minus 1. So you just put in here n of sample size, let's say 61, and you get the degrees of freedom equal to 60. 61 minus 60. Minus 1. I can't speak today. And so now, what is the too complicated? That's another chapter, chapter 17. But the too complicated one, you're going to go right here and go to calculate Welch's degrees of freedom. Here you will enter in the values of your standard deviations and your sample sizes, and it'll put it through the formula. We have the formula right here. This is why I say it's too complicated. It's no longer n minus 1 for the 2 sample t. It's a too complicated formula that we use either applets or software to just tell us the answer, and it does the calculations for us. So you will not calculate what is called the Welch's degrees of freedom for the 2 sample t with unequal variances. Big name to it, Welch, not the grape guy probably. And so we want to be over here on this screen right now, and you want to enter in your degrees of freedom. Once again on your problem, go right here, enter in the degrees of freedom. Step 1. Step 2 is going to be to put in your percent confidence. So step 2 right here, add in percent confidence. So whatever it says, 95, 90, 80. And if you go from 80 to 90 to 95, it gets wider and wider and wider because more confident means less precise, but more confident. So add in the confidence level. We'll do that right here. It says for my interval, I am 95, then 99. So we go back here, we add in the 95, it's already there. The last step is to click between because a confidence interval has the area between the upper and the lower. So we go here, and the last step we need to do is going to be click between. Now the value you get right here, the t, it will be used as a plus or minus, but there's the t right there. And you just drop the t in. Now you change the degrees of freedom to 71 and 99% confidence. So we go back to the problem right here, or the applet, 71 with 99 confidence. Make sure you enter in as a decimal and then grab this. Make sure the decimal places are right, however many decimals it wants. It was set to 2, which the question wants to, and now you get the question right. Same thing for this one, but you can guess these a lot of times. This one's tough. The second one's easier. This one will be 1.66. This one's tough, though. Oh, is it seriously lower? Maybe at 8? Wow. This high? Might be. Oh, the answer, 10 degrees of freedom, 98% confidence. So 10 degrees of freedom, 98% confidence, 2.76. Wow, that's higher than I thought it would be. It kept going up if you notice. 0.76. And the reason we can kind of do these, so these are the same problems since I'm not working them, so ooh, I'll have no idea on that one. I can guess this one right here. This one's 1.98, that's obvious. And I'll tell you why it's obvious in a second. What is the critical value? Which one are you asking about right here? The critical value is the t used to create the interval, Savannah. Sorry, I didn't see that. So the critical value, I'll show you exactly what it is. This one I'm going to have virtually no guess at. If I get this, it's amazing. That is 2 degrees of freedom, 98% confidence. And I'll show visually here. 2 degrees of freedom, 98% confidence. It's this. That is so hard to guess. So the critical value is going to be this value right here. This is the critical value. It is the t used to make the interval. Does that make sense, Savannah, right there? They call it critical value. I just say the t used to make the interval. So the t is relative to how confident you are because of the star, and the t has n-1 degrees of freedom. So when it says find the t critical value, I'm just saying find the t to use to make the interval. Does that make sense? Yeah, just use the applet. It's just the t for the interval. So they call it a critical value. I've never been a fan of it called critical. I don't know why. Why is it called critical value? I don't. Why is t called the critical? I'm gonna go to UTAI and ask it. Why is it called the critical value? I just never. I don't know why we call it that. The t also approaches the z, so it's really hard to guess it with low degrees of freedom, but with high degrees of freedom, it's easier to guess. Low degrees of freedom, it's just tougher to guess. This is gonna be like 2.88. I'll get 50% again. Yep. Because the top one there has so low degrees of freedom, and when it has low degrees of freedom, it's going to be very stretched out. It becomes the normal as you go up towards degrees of freedom. So I hope that helps out with this one right here, but this is how to find the t value used to make the interval, and check out the steps right here that we've listed to get them. So I've got all the steps right here listed. First, enter in your degrees of freedom, then add in the percent, and then make sure to click between. And the T applet is in the chat right now. Ubot has it pinned, so check out the T applet right there. We'll do the next one. We'll just go in order. Keep doing these. Okay, the next question says, which of the following is true for T distributions? Now, here's what's really cool. Let me mark this. Okay, marking it in the notes. 1, 26, 13, 21, 14. Which of the following is true? So when we talk about the t right here, we're talking about Gosset's t. The t distribution, probably one of my favorite pictures, is from Guinness, which you should know. William Gossett worked at Guinness. Guinness beer, where he was hanging out, drinking beers, on business. Guinness. Here it is. And I'm looking for this picture right here. Copy picture, copy image. Bring it over to the screen. So there it is. William Gosset's plaque at Guinness. Statistician and brewer. Sorry, it's all blurry right there. But there is the T right there. The T is the one that is pushed down with the fatter tails to it. So lived in Holy Park on the site. Nice. It might be A and C. It might be. So the T has with it degrees of freedom. The degrees of freedom tell you how normal it is. When the T has more degrees of freedom, we'll go over here, it is more normal. Take a look at this. That doesn't look normal at all. As you go up in degrees of freedom, it becomes more normal. So as the question states, let's go look at what it asks. First thing it says is, as the degrees of freedom increase, the T goes towards the normal. Very true. T has fatter tails and is narrower towards the center than the normal. Does the T right here look to have fatter tails? There's the tails, and is more narrow. Does the T look to have fatter tails and more narrow? At lower degrees of freedom, it should say. The answer is yes. The T has more area in the tails and is more narrow towards the center. So that is a fact. The T is unimodal symmetric. Yeah, we just saw it a second ago. T is unimodal symmetric. There it is. There's the T, unimodal symmetric. I mean, for all intents and purposes, the T, especially at high degrees of freedom, is basically the what? As degrees of freedom go up, T approaches the what distribution. So as degrees of freedom go up, as degrees of freedom increase, the T will go towards the what? Go towards the normal. And here's another graphic showing that. There's the normal with green, and as degrees of freedom increase, and you can see the fatter tails because the normal's the green, T has more area in the tails, but as degrees of freedom go up, it approaches the normal. And is this right here? They show 20 degrees of freedom. A lot of just images showing this, that the T has more area in the tails, and as degrees of freedom go up, it goes towards the normal, which is in dark red right there. So there's a T with less degrees of freedom, and once again, Mr. T comes in, says, "I'll pay the fool," smashes it down. So the T has been smashed down, put in more area in the tails. That's why I really like, I don't know, Mr. T. The reason I like him, he made the distribution. Suppose, in this one we did earlier, for the one sample T, what is the formula for degrees of freedom? For the one sample T, what is the formula for degrees of freedom? n-1, there you go. And that's for the one sample T. Be careful, the two sample T is too complicated. I guess I gotta mark this one. I don't know. was so easy, I might just not even mark it in the notes because it's just, okay, sample size is 15. Okay, degrees of freedom 14 because we're doing a one sample t. You do have to know you're doing a one sample t though, or that would change the calculations on degrees of freedom. Here we go, a little bit longer of a problem. This is another one about the livestock. We just did this one. So you want to speed run it with me, Savannah? We'll just do it really super quickly. Sorry for watching this in the future. Check out the video portion at the end of the homework. This was the last one on the homework. We just did it a second ago. I'm gonna try to explain it, but explain it quickly because we just did it. So we're gonna try to do some new questions right here. So I'm gonna mark this. So we've already done this question. Check out at the end of the homework. You'll see it about the 1 10-minute mark. Go over more in depth. I think we can explain it pretty quickly again. You get repeat questions sometimes. So when you interpret your interval, you always want to do a written interpretation to start. So try doing this right here. We already have, this is the meteorologist one. Always the one before the meteorologist, I think. I am blank % confident that the true blank is contained in the interval blank to blank. So I'm going to interpret my interval. I am 95% confident that the true weight gain of cows is contained in the interval 45 to 67 pounds when they take this supplement. And yeah, let's do it next. You got it, Savannah. We'll finish this one. Do it really quickly right here. Watch the previous video if you need help on it. If other people are watching this. So this interval is incorrect. We know what of the cows studied. No, we're trying to estimate the truth. About the interval, it's about the true mean, not individual cows. A cow? No, it's not about a cow. It's about the truth. I am 95% confident the truth is contained in the interval. So the confidence interval is not for individual cows, it's about the truth. One is 95% sure that the weight gain among the cows in the study. No, we know what the cows gained in the study. We know the cows gained 56 pounds because that's the sample mean from the study. The average weight gain of the cows fed this supplement will be between this and this. No, because the truth is the truth, and the truth will just exist. The truth does not vary. It is a constant. I'm doing this a little quickly, so hopefully I don't miss anything. The supplement were tested on another sample of cows. There's a 95% chance that their average weight gain will be between this and this. Well, no, it's going to be within 2 standard deviations of the truth. So right here, we should get 100. Did it a little quickly, got 100. Check out the previous part of this video at about the 1 hour markish. Check out right there. Let's do the compensation of CEOs. Annual compensation of CEO. Flight times. Oh, that one we need. Oh, I need more coffee. I'll go buy a coffee. Waist size. Why is that here? Delete that. How does the annual compensation of CEOs start out, Savannah? Did I miss it? Oh, here it is right here. Oh, that's why I was like, I don't like this question. Huh. Here's the issue. This question is a chapter, this is from chapter 14 from the last test. This question shouldn't exist. And so we need to remove this question. So I'm going to do this question if anyone has it. I'm going to go over here to ours, and I'd have to remove the full question group. I might just put a bonus on ours, like a 2-point bonus. There's a chance you could get this one, but it shouldn't be here because it's standard deviations of the mean. So for this question right here, we'll mark it. Okay, let's mark it in the notes. But I need to tell Terry question should not exist. No, we've had an old question. Let's do it though. Stat 1, chapter 14 quiz, and a study looked at the annual compensations of CEOs. For this question right here, we are given the theoretical data, or the simulation data, and asked to do the theoretical. Here's the simulation, but here's the thing. When finding the mean for data, and this is a previous chapter, the mean for samples is the following formula. It's going to be mu y bar equals mu. And the standard deviation is SD y bar equals sigma over square root of n. So all we're going to do is take the sigma, divide by square root of n each time, and put the mean in. The mean won't change. Literally, every answer right here will just be the mean. These will be an increasing sigma, whatever sigma is, divided by square root of 30, sigma divided by square root of 50. Notice it's going to get smaller, which is what happens as you go to bigger sample sizes. And this is the standard deviation of y bar because it uses sigma, because in this problem we know the truth right here. So notice it does get smaller, and also the distributions will become more normal. So the mean is going to be the mean. So the mean for all these is going to be just the mean, because that is mu y bar equals mu. What in the world am I typing? Got off by one number. That is this right here. And then the standard deviation is going to be the original standard deviation divided by the square root of n. So 30 square root. And we take the standard deviation. There's the new. And we take the original standard, or we do square root of 50. 50 square root and 18,619.59. There we go there. And square root of 100, which is 10. So just move decimal places. 1861.96. And then 200, which is 200 is neat because it's 1414 or 1414, I think. It's 1414, right? There we go, 1414. And so now with that, we take the original standard deviation of 18,619.59, divide by, and there it is. Notice it gets smaller each time as we increase because we're dividing by the square root of n. There we go. Simulations do show they're reasonably close for both, and that's how simulations do, is our values are reasonably close to the simulated values right here. These are simulations meant to estimate the theoretical values. You get 100. There we go. So yeah, previous chapter. Does that make sense, Savannah, right there? Little quickly working through that one, but the formulas for this one are mu y bar equals mu. So we found what mu was. That's the mean at all points. And then sigma over square root of n. Just keep doing the original standard deviation divided by the square root of this, the original standard deviation by the square root of that. So you just increase n right there each time, and you get a smaller and smaller standard deviation. And then simulations done properly will give the theoretical, or close to the theoretical values, reasonably close to them. Someone might be like, they're a little bit off, then we have to increase the amount of simulations we're doing. So same, yeah, awesome. And so let's see, another one. He'll go back to, oh, we need to do this one because this one uses jump. We gotta do some jump work. Okay, you're welcome, Savannah. We'll do the Chips Ahoy Nabisco challenge. I wonder if they got something. I got 100 on my homework because of this. Thank you right there. 1,000 points for you, Catherine. Glad to hear that. These are tougher assignments, but practice, you can do it. You can get the hundreds. You can get them. People tell me sometimes these are too tough, and I say, yeah, just ask what you're stuck on. So this one you have to use jump for, or you can use other things. Yes, this is the chip challenge one. Make sure I got everything closed in jump that I want closed. I was looking at grades. Yep, I just got Pokemon open. Okay, cool. Okay, there we go. Pokemon. Let's go over here. So with this right here, we are going to take this data, copy to clipboard, hit Command C. Make sure to click the little icon there, copy to clipboard, and then hit Command C or Control C on a Mac versus PC. Go into Jump, and inside of Jump, click Control N or File New Data Table. Now don't click inside of it. You can make sure you go to File New Data Table. Don't click inside of it. There, I believe, was no column name with this. It was just data. So go to Edit, Paste. If you pasted with column names, the first value will be put at the top and you only have 13 observations. This is the wrong way. It looks like this. Open a new sheet and paste again. Make sure you have 14 observations, which represent the 14 bags of chips and the amount of chocolate chips counted in each trial. So now we're going to go here with the data and go to Analyze, Distribution. Analyze, Distribution. On Analyze Distribution, we're going to double click the variable of interest, column 1. We could have called it something, but we didn't. Now we click OK. Now that we've clicked OK, we get the histogram, which is kind of unimodal symmetric. We're going to click the top right arrow and do stack. Puts it in horizontal layout. There we go. Next, we're going to go right here and we're going to double click this axis. With the access double clicked, we're going to type in 900 and 1500 and no minor ticks and 0 minor ticks. There we go. And now we click OK. And there you go. There's your histogram. Boop. So we've got the histogram. It keeps pasting wrong. Make sure to go to edit, paste, just paste. So open a data sheet and then just you can hit Control V actually. Let me know, Savannah, right there. Is it working? Thank you. Okay, good. Just Control V, not paste with column names though. No paste with column names, just paste. Control V or Command V works. This instance, sometimes you have to use column names, sometimes you don't. See if the column name is there. If there's no column name, you don't paste with the column name. And the reason is because if you look at the data when you copy it, there's no, you see how there's no column name up here? It's not called like chips, it's just data. So there's no column name, so you just paste, you don't paste with column names. So now you notice we want to check the conditions. Condition 1, randomly selected bags of chips. We probably did that. It's probably random because they took independent bags of chips. Is this less than 10% of all chips? I'd assume so. It's less than 10% of all bags of chips. Easy to assume that, less than 10% condition. Last condition is it needs to come from unimodal symmetric data, nearly normal data. And you know, when you look at the data, is it unimodal symmetric? Yeah, it pretty much is. So we're good on all that. The sample data is random, so we can assume that they're independent. Cool. How does the data look? Notice that the axes are, we made ours look like this. That's where I double clicked the axis and I changed it to 900 to, I guess I should have done 1600. You double click the axis, no minor ticks. And then it looks just like, nope, this one, there it is. Looks like that one. Once again, double click this, enter in the values, and you can get it to look exactly like it. Yep. And now we go here. Even evaluate the histogram. Well, it's unimodal symmetric with no outliers, so one can assume the data comes from a population that follows a normal. I think this one gets me sometimes. This one gets me because I can't remember if they do. So be very careful. Pause on this one because, yeah, because the population would follow the normal. We're going to do the interval with the t. So the population should follow a normal because this is a nearly normal condition. And when you don't do this to me, my Pearson, because then I outthink myself because I get it wrong sometimes. This one gets me. Be very careful. Watch what I get right or wrong. I think I'll get it right this time. Population should follow normal. We'll use the t to create the interval. So here we are with create the 95% confidence interval. To create the 95% confidence interval, we just look at the output. There we go. I am 95% confident. The true mean amount of chips in a bag is contained in the interval 118144. 1 decimal. That's how I get things wrong. 1. And then the upper was 12976. Good deal. What does the confidence interval say about the Nabisco's claim that you get 1,000 chips in a bag? Well, this is on average. I'll show you again, Brooklyn, you got it. This is on average. So it's not about one bag of chips, it's on average. So remember, I am 95% confident the true mean on average, we would see this many chips. So because the confidence interval is above, the mean number of chips per bags is likely more than this. However, the normal model predicts that a small amount of individual bags will have less than this, and we did get 100. To make a histogram, make sure to go over here with your data. And with your data, go to Analyze Distribution. Analyze Distribution. Analyze Distribution. Then double click the column and then click OK. Now we have the distribution made, and then go to the top right arrow, click Stack, and there you are. The data. Did that help out right there? Let's see, go back to here to start. Another interpretation one, we can do it. Done a lot of these interpretation ones. Interpretation's good. Yeah, you're welcome. Great job right there. Stacking just makes it look nice. It helps out with looking at it and reading it. So, okay. Of salaries, software analysis of salaries. There we are with software analysis of salaries, and we've got an interval. I am 90% confident that the true mean of tech pay, how much they're paying in Nevada? Oh, teachers. Is contained in the interval of teacher pay, not tech pay. I am 90% confident the true mean of teacher pay is contained in the interval $43,454 to $45,398. So let's look at what they interpret here and see if it's right. If many random samples of 288 teachers from Nevada were taken, about 9 out of 10 of them would produce conference rolls. Wait, what? About 9 out of 10, oh, that would produce this interval? No, way less would produce the interval. The interval is created from this data. This is incorrect. Yeah, 9 out of 10 would contain the truth. It all produce different intervals. Yeah, 9 out of 10 would expect the truth, about 90% of 90% intervals. Weird answer. If many random samples of teachers from Nevada were taken, about 9 out of 10 of them would produce a conference roll that contained the mean salary of all teachers. Okay. That's theory on interval. That sounds right. If many random samples of teachers from Nevada were taken, about 9 out of 10 of them would produce intervals that contain the mean salary. I'm scared, but that sounds right, because 90% of 90% conference rolls contain the truth, and that's what you should understand about them theoretically. That's not the interpretation of the interval. It's what the interval means. It's 90% of 90% conference rolls contain the truth. So, yeah. About 9 out of 10 teachers from Nevada, no, it's not about individual teachers, it's about the true mean. So it's not about individuals. The interval is for the population mean, not individual teachers. About 9 out of 10 teachers surveyed. No, we know what the survey data is. So the interval is for the sample mean, not the salary of individual teachers. That sounds correct. Oh, no, it's not about the sample mean. What am I saying? They're tricking me. It's about the population mean. The interval's for the true mean, the population mean. We are 90% confident that the average salary teacher in the entire... No, it's not the entire country. It's about Nevada. So the conference interval only addresses... the conference interval addresses only the salaries of teachers in Nevada. That's right there. We should get 100. Woo! Ooh, the theory one got me, because this one is not an interpretation of the interval. It's the theory of the interval, that 90% of 90% conference intervals, the repeated long run. We have a really good note on this. So let me show you from the chapter 13/14 notes. Just showed up and then went away. The notes on this are excellent. Got to give shout outs to our notes. Thank you to everyone. I've worked on the notes. Terry's worked on the notes. And it's shown to you. I think I just went by it. Here's what do conference intervals really mean. I'll go to the screen. Here it is. This is the notes on it. And it's not that one on conference interval contains the truth. There's a conference interval right here that does not contain the truth. Here's one that does. So if we're doing 90% conference intervals, we would expect 90% of 90% conference intervals to contain the truth. So if you were to say you made repeated intervals, about 9 out of 10 of those intervals that were made would contain the truth. So that is a fact. That is the theory of the interval. This is the same sort of thing. Interpretations again. 95% of all students. No, it's the average. It's not what the student's paying. So we could do that one, but that's very, very similar. We did the snow one. We did that one in the homework. Medical researcher, pulse and beats per minute. This one's pretty good. The margin of error one. If you have questions, let me know. We're getting close to the end of office hours, but got time for a few more here. Just trying to put a few more questions in this video. Is it going to storm today? Is it currently storming? Okay, a medical researcher estimates the true average pulse rate of people to be in the interval 63.1 to 67.07. I got really lucky with this interval. So think about how we interpret this. I am 95% confident. Good to see you there. Ask questions if you got it. I think I'm about to make you mod too, because I think I know. If you have questions, let me know. I think I know which section you're in. I add you as a mod. Recognize the name in the chat. So this is a very common question, especially when it comes to the tests. I thought it was. What we have here is the interpretation of the interval. I am. Your histogram doesn't look right. Oh, which problem, Savannah? I am 95% confident that the true something is contained in the interval something to something. Know the interpretation. So I am 95% confident the true mean pulse rate of people is contained in the interval blank to blank. We are 95% confident the interval contains the true mean. True. Now the margin of error. So Savannah, I want you to try this one. What is the margin of error of an interval that goes from 63 to 67? What is the margin of error of an interval that goes from 63 to 67? What is the margin of error of an interval that goes from 63 to 67? What is the margin of error of an interval that goes from 63 to 67? We have to come up with examples we can do very quickly and easily. What is the margin of error of an interval that goes from 63 to 67? So you should be able to write it as an estimate plus or minus the margin of error. The estimate is the center of the interval. The margin of error is the plus or minus. So the estimate is our best guess of the truth. So this is where y bar is at. It's at the center of the interval. So when you do a constant for the mean, the lower is down here on the lower side. The upper is up here on the upper side. That's the lower bound and the upper bound. Oh. Does anyone know what the margin of error is? 1,000 points if you know it. This is the lower bound, the upper bound, margin of error. Right here, this is a margin of error. That's a margin of error. If you look at the margin of error, it's half the length of the interval. This is the length of the interval. The length of an interval, which would be margin of error, blue. Margin of error equals upper or minus lower divided by 2. Half the length of the interval. So we simply plug in upper minus lower divided by 2, but I mean, just think, if we rewrite this interval could be written as, this would be 65 is the estimate, plus or minus 2. There you go. And that's the interval. And they gave me nice numbers because the decimals are nice enough that it actually rounds to this. And if we had made a 99% interval, as we've seen with the applet, increasing confidence makes the interval wider, and you break the applet because it's more area being covered. So when you go to a lower confidence level, then the interval is tighter, and higher confidence, increasing to like 80% confidence or 90, is going to make the interval wider by increasing the t. So the interval would have been larger with higher confidence. There we go, right there. Once again, the formula to get this is upper. And it doesn't want that many decimals, so we're just going to go to 4 minus lower. And that's the distance the numbers are away, divided by 2. There we go. And that rounds to 2 right there. Basically, it was 63 to 67, and that's why I was like, ooh, those numbers are nice right there. So 63 to 67, the lower bound, the upper bound, the estimates at the center of the interval, 65. So you can actually get the estimate by averaging the two numbers together because they kind of average in towards the center. And being able to draw stuff like this is key because it helps with understanding the theory of what you're doing to solve the problems. So now the flight one here, we've done a few like this, or I'm trying to think, which one, Savannah, is everything working all right? These other ones are calculation ones. Which one? I have time for only one more. No. We'll do one more by hand calculation one. We did a few of them during the homework assignment. Is this a data one or there it is? Okay, so let's do this one right here to finish off. Drop a question if you have it. This will be probably one of the last questions today. 154, 33, stat 201, chapter 14 quiz. Will your flight get to your destination on time? A government bureau reported the percent of flights that were delayed each month from 1994 to June 2016. The accompanying histogram and summary statistics right there provide the percentage of flights that were delayed. We consider these data to be representative of all months. There's no evidence of a time trend. I think this one has a little bit of a trick right here because it's not really a random sample. And so, not really a random sample. It is pretty normal. They're not really independent. I throw a trick on this one. It's a good one to end on because I might get something wrong. I think we've gone perfect today so far, except for the ones I was guessing. Now they want you to make the interval right here, and you would say, I am 90% confident that the true proportion or true mean proportion, it's kind of weird right there. It is mean still. Here it is monthly percentage. I am 90% confident that the true mean monthly percentage of flights that arrive late will be contained in this interval. I wish they said it that way. I'm going to enter in 2 and 2 right here just to see if I have the other right answers. Ooh, I got a 0. Wait, what? There is 90% confidence interval contains the mean monthly percentage. Oh, because they don't like the fall word. Okay. And then for the top one right here, that's what they want. The problem is it's a time series, and Pearson, so I want to show you the answers before I calculate the interval. It's a time series, which time series data is usually not independent. So I'm kind of iffy on the independence there because each data point to each data point is dependent, so to say. So going at this from the theory of time series, I have a problem made with independence. It's also not randomly collected data, and that kind of goes into this. Like, that's why I'm like, really? But once again, they don't like the falls word there, which I agree. Statistically speaking, we don't say the word falls. That's why I'd prefer just to write out my interpretation. I am 90% confident that the true proportion or true mean monthly percentage of flights that arrive late is contained in the interval blank to blank. So I just write mine out usually rather than use theirs. So for this problem, we need to use the summary statistics. So we go ahead and take the summary statistics right here. And our questions on the test are super duper clear. Oh, Pearson. Like, you had to get something wrong. And we have to write out our equation. So to write the equation, we write y bar plus or minus t with n minus 1 degrees of freedom, s over square root of n. And look at that. They basically told us what the problem is. They go here, go here. Look at all the data we get. We get it just handed to us. Like, here you, oh, wait a minute, we don't have a t. Well, the t uses n minus 1 degrees of freedom, so degrees of freedom are going to be 269. We wrote a little cheat sheet earlier today on how to use the applets to do the degrees of freedom. So, or to get your t critical value, you need to go to the applet, which is currently pinned. We'll have MuBot drop it again right here. The t applet is right there in the chat. Click it and go over to the t applet. So I know you got a short memory, MuBot. Remember everything though, I swear. And so you go here to the t applet. You enter in your degrees of freedom, which are 269 because the sample size was 270. We are making a 90% confidence interval, and you click between, and there is the value, 1.65. 1.65 for 90%. Here's the steps. Enter your degrees of freedom for the one sample t, it's n minus 1. Add it in percent confident you are, and then click between. Make sure to follow those steps. Degrees of freedom, confidence level, click between to make an interval. 1.65. So that is the t for 90% confident, and with 269 degrees of freedom. So 1.65, 1.65 found from the applet, 1.201 square root of 270, and then plus or minus the, there we go there, and 270 square root, and that's still 270 square root. Now 4.201 divided by that. standard error times by 1.65. That's the margin of error. And now 0.4218. 4218. Go over here, back to our assignment. This 19 something. Oh no, 19.7. 19.67. 19.67 plus this 20. Minus. There we go. That should be right. Tell me I'm right, please. Woo! Got scared. Oh, that's got it. We'll be doing officer starting at 2 today. I'll see everyone later. Great job. Bye for now.